the pendulum swings from P to Q to R and back to P. P is 10 centimeter higher than Q. At which speed does pendulum passes through Q? So we know while swinging, potential and kinetic energy change, but energy is conserved, which means potential energy has to be equal change of kinetic energy. In a simple way, we can use just one step. mgh is equal to half mv squared. We have no information about mass. It can be cancelled from both sides. G is 10, which is known. At height is centimeter, so you have to convert from centimeter to meter simply by divide over 100. So 10 over 100 is equal to half v squared. Using calculator, finally you get that v is 1.4 meter per second. Going here, talking about efficiency and how are we able to use this information. If a machine has an efficiency of 75%, what does this mean? 75%, it refers to total amount of input energy changes to be useful or changes to be used or useful energy. So try to pick the answer that matches this description, which is 75% of energy supplied is transferred to useful energy output, which is similar to our description. Here, the diagram shows the energy used by a modern lamp, which expression gives the efficiency. Okay, as we can see, we notice here the total input is 60 using our Sankey diagram. So total output is 60 watt. This power will be converted into useful energy and wasted energy. This is the useful energy because it's written here, useful energy. So it will be 12 watt. Then what the rest, which is 50 minus 12, it will be converted or will be wasted. So which is 38 watt. Now, which one of these expressions shows the efficiency? Normally, to calculate efficiency, we use the formula of useful energy or useful energy, used energy over total, right? Over total input times 100. So what is the useful energy is 12. Total is 60 times 100. This is the best expression to show efficiency. The diagram represents the energy transfers from a device. The device is 50% efficiency automatically without even thinking. 50%, this means total input is divided into two, like half and half. If 50% is used, 50% will be wasted. So automatically here, wasted is equal to useful energy, useful output. Wasted output is equal to useful output. Going to question 15. A lamp has a power input at 5. It wastes 10. So again, if we need just to draw it to visualize the situation. So total is 5 watt. 1 watt is wasted. This means 4 will be used. So what is the efficiency? Efficiency, total used output, which is 4, over total input, 5 times 100, it gives 80%. The thinking diagram below shows the energy input and output in 1 second. What is the useful energy in 1 second? Okay, so again, same scenario. 10 is the total input. 8.2 has been wasted, so mainly you subtract minus 8.2, it gives 1.2 joules. Okay, sometimes it might be replaced or gives information about power instead of energy. And instead of energy, it could be power. So the measuring unit here will be watt. Again, here will be useful power if information gives about power. And power, in this case, measuring unit will be watt. Yes? I'm just giving you the question in different scenario.